You are standing on the most solid thing you know. The floor. The ground. The one surface that has never once let you down. You trust it without a single thought. It is the very definition of stillness, of safety, of the word solid itself. But the real answer is far stranger. Because a few thousand miles straight down, hidden beneath every road you've walked and every place you've slept, there is a ball of iron burning as hot as the surface of the sun. And you are standing on it right now. Not near it. On it. Think about what that means. The sun is the brightest, most violent thing you have ever seen. You cannot look at it. You cannot touch it. It is the untouchable furnace at the center of everything. And yet the same searing temperature that scorches the face of that star is sitting quietly under your shoes, right this second, holding you up. How is that even possible? How can the ground feel so cold and still and dead, while something star-hot hides just below it? To understand that, you have to understand something no human has ever done. No one has ever been to the center of the earth. No drill has ever come close. The deepest hole humans have ever dug reaches barely 7 miles down, and the center is nearly 4,000 miles away. Everything you are about to learn was discovered without anyone ever going there. So how do you weigh a fire you can never reach? You listen to it. In 1936, a Danish seismologist named Inge Lehmann was studying earthquakes. When the ground shakes somewhere on Earth, it sends waves rippling straight through the whole planet, like sound moving through a bell. Lehmann noticed something strange in those waves. Some of them bent in a way that made no sense. They behaved as if, deep in the core, they had struck something hard and bounced. Everyone at the time believed the center of the Earth was a single liquid ball. Lehmann disagreed. She proposed that inside the molten outer core, there was a second, hidden core. A solid one. A metal heart within a metal sea. She was right. And she found it using nothing but the echoes of distant earthquakes. That is the first surprise. The center of the Earth is not one thing. It is a sphere of solid iron and nickel, about the size of the moon, floating in an ocean of liquid metal, wrapped in thousands of miles of slow-flowing rock. And every layer of it is unimaginably hot. But how hot, exactly? That question took much longer to answer, and it is where the story becomes almost unbelievable. The center of the Earth is under crushing pressure. All the weight of the entire planet pressing inward, squeezing that iron core with a force more than 3 million times the pressure of the air around you right now. And here is the problem. Pressure changes everything. It changes how metal melts. It changes at what temperature iron turns from solid to liquid. So to know how hot the core is, you first have to know how iron behaves under a pressure no laboratory on Earth normally reaches. For decades, scientists could only guess. Then, in 2013, a physicist named Simone Anzolini and his colleagues did something remarkable. They took a tiny fleck of iron and crushed it between the tips of 2 diamonds, squeezing it to the same brutal pressure found at the boundary of the inner core. Then they blasted it with lasers and watched, in real time, using intense X-rays, the exact instant the iron began to melt. What they found reshaped the number in every textbook. At the edge of Earth's inner core, iron melts at around 6,000 degrees Celsius. 6,000 degrees. The surface of the sun burns at roughly 5,500. So the center of the Earth is not just as hot as the sun's surface. In places, it may be even hotter. Sit with that for a moment. The star that lights your sky, that grows your food, that has terrified and inspired every human who ever lived, is matched in raw heat by a hidden thing beneath your feet that you never think about at all. But now you should be confused. Deeply confused. Because Anzolini measured the temperature at which iron melts down there. And the inner core, the thing Inge Lehmann discovered, is solid. If it is 6,000 degrees, and iron melts at 6,000 degrees, why hasn't it turned to liquid? Why is there a solid ball at the center of a furnace hot enough to melt it? The answer is the pressure again. Down there, the squeeze is so extreme that it forces the iron atoms to lock together into a solid, even at temperatures that would vaporize them up here. Heat wants to tear the atoms apart. Pressure refuses to let go. And pressure wins. So the center of the Earth is solid, not because it is cold, but because it is being crushed too hard to melt. It is star-hot and rock-hard at the same time. Both at once. A frozen fire. Does that break your sense of how the world works? It should. Because everything your body knows about heat comes from living on the thin, cool skin of this planet, where hot things flow and melt and burn. Go deep enough, and even those rules bend. Now comes the question that changes everything. Where does all this heat actually come from? What is keeping a fire the size of the moon burning in the dark, 4,000 miles down, for billions of years? There are two answers, and both are astonishing. The first is memory. When the Earth formed, 4.5 billion years ago, it was built from countless colliding rocks and dust, slamming together again and again. Every collision released heat. As the young planet grew, the heaviest metals, the iron and nickel, sank toward the center, and their falling released even more heat, like a weight dropping and warming the floor where it lands. That primordial heat, the leftover warmth from the day the planet was born, is still trapped inside. The Earth is, in a sense, still glowing from its own creation. The second answer is even stranger. Deep inside the Earth, there are atoms that are quietly falling apart. Uranium. Thorium. A rare form of potassium. These are radioactive elements, which simply means their atoms are unstable and slowly break down, and every time one breaks, it releases a tiny burst of heat. Multiply that by the unimaginable number of such atoms buried in the Earth, and it becomes a planetary engine. The rock beneath you is warming itself from within, atom by atom, decay by decay. For a long time, nobody could measure how much of the heat came from this decay. It was happening too deep to see. Until scientists found a way to catch its ghost. When those radioactive atoms break apart, they fire off nearly invisible particles called geoneutrinos, particles so faint they pass through the entire planet without touching anything. In 2005, an experiment in Japan called Camland, buried deep inside a mountain, managed to catch a handful of these particles as they streamed out of the Earth. For the first time, humans directly detected the heat of radioactive decay leaking from inside their own planet. They were, quite literally, watching the Earth's inner fire by the light of particles born 1,000 miles down. So the heat under your feet is two things woven together. The ancient warmth of the planet's birth, and the ongoing whisper of atoms tearing themselves apart. Between them, they keep the core near 6,000 degrees, and they have done so for longer than life itself has existed. And here is where it stops being a fact about geology and becomes a fact about you. That buried furnace is not sealed away, doing nothing. It is the reason you are alive. The liquid iron of the outer core is churning, driven by all that heat rising from the center. And churning liquid metal generates something invisible. A magnetic field. That field stretches out from the core, through the rock, past your feet, past your body, and thousands of miles out into space, wrapping the entire planet in a shield you cannot see. That shield is the only thing standing between you and the sun's deadly radiation, the stream of charged particles that would otherwise strip away the air you breathe. Every compass that ever guided a ship points north because of that spinning core. Every bird that migrates across a continent reads that field like a map. The northern lights glow because that shield is catching the sun's fire and turning it into color. You owe your sky, your air, and your safety to a star-hot heart you will never see. So the next time your feet touch the floor, remember what you are really standing on. Not a dead, cold, unmoving thing. You are standing on the thin, cooled crust of a molten world, and beneath it, a fire as old as the planet and as hot as a star turns slowly in the dark, holding your entire world together. You are standing on the most solid thing you know. You are standing on a star.